So my name is Anda Catalina Kelba. I'm working as a cloud engineer within amanox since the beginning of 2020. I have a background in telecommunications, and before I worked as a software engineer at CERN. So I'm looking forward to the hackathon and to see the different teams and to the energy that we're going to have during the weekend. Okay, moving forward, I want to say 2 words about amanox solutions. So we are an IT solution provider with focus on enterprise cloud data center solutions. So we can provide help on what we call private and public cloud solutions. We operate throughout Switzerland and we have the headquarters in Bern. And our clients are from medium-sized companies, enterprise and service providers that are spread across our industries. So this is just to have an idea about who is amanox Solutions and what we do. And now we're going to move forward with the agenda of today. So I'm going to do a short intro, and then we're going to discuss about the AWS global infrastructure. Then for today, I chose 3 of the base services available in AWS, which are the VPC, the EC2, and S3. So we're going to see together an overview of these 3 services. And at the end, I'm going to give you some additional information that might be useful for you. So if you have any question, please write a question mark in the chat or write the question directly in the chat. Also, let me know if there are issues with the voice, the video, or the lagging. I hope we're not going to have any troubles during the presentation and nothing that's going to bug. Okay, so let's get started. So we're talking about cloud. And let's start with one of the main advantages of the cloud, which is the agility of cloud computing. And that will be the ability to replace what would initially will have the capital infrastructure expenses with low variable costs that help enterprises to grow their businesses. So traditionally, we'll need to anticipate the costs and to calculate in order to order the needed infrastructure and to put it in place to install it. But now with the cloud computing, we are way more agile to do it, and in a matter of a couple of seconds, a couple of clicks, we can instantly run hundreds or even thousands of servers and deliver results way faster. So with AWS, there is no minimum commitment or no long-term contracts, and it's very helpful to innovate faster nowadays. Next, we are going to see an overview of some of the basic services. So just know that today there are a lot of services, highly reliable, scalable, and low-cost infrastructure. And the services are powered on over 190 countries around the world. So some of the core services that we have are around compute, networking, storage, databases. And today we're going to see an overview about the Amazon EC2, the Amazon VPC, and the Amazon S3. So as I was saying, this is only an overview of basic services, because every year we have more and more announcements that are made and new functionalities and services that are coming up. And for instance, in 2019, we had nearly 2,000 announcements that were made. So you can imagine that it's evolving pretty fast, and we also need to keep up with the new functionalities and services. So today we have more than 5,000 services and functionalities that are offered. These functionalities are grouped into about 200 services, and of course, we can ask ourselves if we need to know all these 200 services or not from the beginning. But to answer this, there is a principle that you might already know that is called the 80-20 principle or the Pareto law, which says that about 20% of the causes are product 80% of the effects. I'm going to reformulate. So about 80% of the effects are the product of 20% of the causes. So meaning that there are about 30 and 40 major services that will be used by almost everyone. So in general, in order to answer 80% of the use cases, we'll need to have a look at only about 30 services. And I think this is an important principle to bear in mind at the beginning, at least. Okay, are there any questions so far?
So we are still here, but no questions.
Okay, thank you. So then we're going to move forward and to see the AWS global infrastructure. So the AWS network is divided into regions which correspond to geographic locations. So each region contains several high availability zones, and each availability zone is designed to be isolated from failures from other availability zones. So in each availability zone, we're going to have multiple data centers that resides, and we don't actually see them. We only have access to these availability zones. And something else that also we have are something that we called points of presence that will be edge locations. So this is also a subject that today we're talking about edge points and how to bring compute power more closely to businesses. So today there are 24 launched regions. So the regions are the ones that you can see in orange. The ones in green, there are 3 announced regions today, which are Spain, Jakarta, and Osaka, I think. And the total will have around 77 availability zones. So this is to give you an overview of the global infrastructure map and to see what AWS built around the world. So of course, as the businesses are growing and the needs also evolve, AWS, they continue to provide new infrastructure at the global level. So more specifically, inside the region, we're going to have at least 2 availability zones. We can ask ourselves why. So this will be because if there is a problem in one availability zone and it fails, then we have a second one that is nearby that can take over the loads by the availability zone that failed. And here we have also an example of 2 regions with their associated availability zones. So we can see, for example, that in North Virginia today there are 6 availability zones, and Ireland, which is a region in Europe, there are 3 availability zones. So this will be the names that are used inside the AWS services. And when we talk about the availability zones, we're talking about AZ, A, B, C. So that, I think, would be all about the global infrastructure.
Sorry, I can't really write the chat. Teams give me an error message, but is there something in Switzerland?
So in Switzerland, concerning a region, there is no official information. So we don't have an announced region for Switzerland, at least yet. And what we're going to have in Switzerland will be more points of presence, and also something else that will allow, for example, if you want to directly connect to the backbone of the AWS, it is possible from Switzerland directly also.
Okay, so more connectivity things, because it's always a topic with banks and stuff like that to have hosting in Switzerland.
Yeah, exactly. Yeah, I know the banks, but the thing is that from what I know and what I was able to follow concerning this issue, there were some communications. I don't remember exactly the name, but this I can look it up if you're interested and follow with the link afterwards. That was saying we can design actually the architecture inside AWS in order to correspond to the needs of the Swiss banks.
Okay.
But then, of course, we need to have a closer look to evaluate it and to be more careful about the decisions that we take, because it's a, let's say, a particular use case.
Okay.
But
Thanks.
yeah.
Thanks.
Yeah, sure, no problem. Okay, then we move forward with the first service that we're going to see, which is about networking. So VPC stands for Virtual Private Cloud, which would be a virtual network topology that will closely resemble to what we call a traditional network that you might already have seen or not, or it's something that we can also find in the private data centers. So if with the VPC, you have the control, the complete control over the environment, over the virtual networking environment, and you can easily customize the network configuration for your virtual network, such as selection of IP address range, creation of subnets, configuration of route tables, and network gateways. So AWS, so when you create a VPC, you're going to define also some subnets, and there are unique IDs to each subnet. So regardless the type of the subnet, which we can have to public or private, the internal IP address range of the subnet is always private. Then let's define what we call a private and a public subnet. So a public subnet would be a subnet with a route to the internet gateway, for example, for a web server that is going to be accessible from the internet. And then a private subnet is not going to have a route to an internet gateway, and we're going to use it for a database server only access within the VPC. So also each subnet will reside inside one availability zone, and we cannot span it over availability zones. So as I was saying, you can easily customize the network and configuration for the VPC. And here we have an example where we can see that inside the AWS, we have our own VPC, and then we have a public subnet and a private subnet. So in the public are the web servers that are going to be accessible from the internet using an internet gateway. And in a private subnet, we're going to have, we can have our application servers that are only going to be accessible within the VPC. So there's no connection here to the internet. And something else that we can have here will be a VPN, so virtual private network, only subnet that we can interconnect with a private network, for example, if that's needed, and we can leverage AWS functionalities while still having a private cloud. So there are also different layers of security that we can define, which we call security groups and network access control lists, and this will allow us to control the access to our servers, for example, in each subnet. So that was the overview concerning the VPC. Are there any questions concerning this part? So I guess no. Then we can move forward to the Compute EC2. So EC2 stands for Elastic Compute Cloud, and they are virtualized servers in Amazon's data centers. So what we say is that they are designed to make the web scale computing easier for developers. We have simple web interfaces where we can easily configure the capacity. We can so we have a complete control of the computing resources, and we can easily configure different parameters. What's also interesting is that the time required to obtain and boot new server instances is quite low, and this help us to be more agile and to quickly scale the capacity based on the computing requirements changements. So this is also interesting, of course, from an economical point of view. And why? Because we are also going to pay only the capacity that we actually use. And then there are different tools that we can use to build what we call failure resilient applications and to isolate applications from common failure scenarios. So we have a true virtual computing environment that we can use to launch instances with a variety of operating systems, to load them with our custom application environments, to manage the network access permissions, and we can also run our own image or choose an image that is proposed in the system. So you can also choose between Linux and Windows. You can programmatically scale the computing capacity based on the requirements. So if you need at one point, for example, to add what we call 2 instances, which will be maybe on common language to servers, so we can automatically do it, or if we need to reduce them and to stop them, this is also possible. And of course, we can leverage the global infrastructure of AWS that we saw earlier to deploy across different regions and availability zones for reliability. So also being in Europe, we can choose to deploy in the US if we have customers there and we want to be more closely to them. So in order to improve the latency and the throughput, would be more interesting for us to go directly in a region there to deploy near our customers. We also have a wide selection of instance types that are optimized for different use cases and workload requirements. Most are based on Intel Xeon processors, And there are different things that we generally consider before choosing the instance type. So the common questions that we're going to ask ourselves will be, how many cores do we need? What's the memory size that we need? The storage size and the storage type. Maybe we have some network constraints that we need an important network performance. And also, maybe we have an interest on the CPU that is used, as they also propose different CPU technologies. So for the time being, bear in mind that there are different families that are proposed, and of course, you can choose the one that best fits your use case. So this is something that I a little bit already mentioned by scaling your instances, like adding new ones or deleting existing instances programmatically. And I want to simply explain you how this works, as this is a main advantage that we have with the cloud services. So here we'll have, let's say, monitoring services that we're going to define some rules on it. And based on those rules, we're going to say that, hey, if you reach 80% of the compute capacity and more requests are coming in, then maybe we're going to add new servers so that we're going to be able to provide our services at a good latency to our customers. So then we're going to use a service that is called autoscaling, and this service is going to add new instances that is going to make them available. And then is going to discuss with another server saying, hey, here are your new instances that I created. Please take them into account. And when you have new requests coming in, also distribute these requests to the new instances. So also is elastic load balancing. So it's balancing the load that's coming in. And then the load balancer will report some metrics also to the monitoring service. And then we start again the loop on, and if needed, we create new servers, or in the same way, if we say, hey, now we're only using 20% of our computing capacity and we have maybe 10 servers, is it possible maybe to shut down 5 of them? Okay, then autoscaling, please shut down 5 instances, and then this service is going to talk to the other one saying, hey, these 5 instances are not longer available, so please don't take them into account. And that's how it's working. So if you have any questions concerning this, please ask them. Might be a little bit tricky at the beginning, but once we get how it's working, it's quite simple. Okay, if no, we're moving forward. And we're going to talk about an object storage service, which is called S3, and it stands for Simple Storage Service. So this is designed to make the web scale computing easier for developers. So it provides a simple web service interface that can be used to store and to retrieve any amount of data at any time from anywhere on the web. So it gives access to everybody to the same highly scalable, reliable, secure, what we call fast, inexpensive infrastructure already existing that Amazon uses to run its own global network of websites. So there are some facts about the S3 service. So you can store an unlimited number of objects in what we call a bucket. And there is actually a limit of 100 buckets per account, per AWS account. So the size of an object can be up to 5 terabytes, but there is no limit to the size of a bucket. This service S3, so it's designed for what we call the 11 nines of durability. So this would be 99.9999. So 11 nines and 99.99% of availability of objects over a given year. We can use both HTTP or HTTPS endpoints to store and to retrieve any amount of data at any time, anywhere on the web. So the most important, what maybe you need to stay with, is that S3 is highly scalable, reliable, fast, and inexpensive. So it's widely used. It's a widely used service, and there are different common use cases for this service. So we can use for storage and backup, file hosting, software delivery. So for example, we can host a static website on Amazon S3. So we were going to configure a bucket for the web hosting, and then we're just uploading our content to the website, our website content to the bucket. So this is pretty useful. If you have only a static website, just know that you can use S3, and you don't need an EC2 instance, a server to upload your content. Okay, are there any questions by this point, as we had an overview of these 3 services? Okay.
Pretty clear to me, thanks.
Okay. Then I'll give you some additional information, which I think is pretty useful when starting with AWS services. As we saw, there are different functionalities and services available, which is, we can consider that it's a complex software. We can, of course, ask ourselves how we're going to be able to estimate the costs, because we saw that we have different instance types. There are also different sizes. We can choose between the CPU. So of course the prices are different based on everything. So for this, we have the simple monthly calculator, which is pretty useful if you want to estimate how much your architecture is going to cost, or even for a personal project, for maybe a personal website that you want to put in there. I have friends that they do video game streaming, and they host their video games on AWS during the stream. So this is a useful tool to estimate how much is going to cost you if you want to use the services. And of course, as you can see here, per service, you can add exactly the features that you want to use, and then he's going, based on, of course, on the region also, he's going to, at the end, to sum up everything and give you a number. This is something more interesting when you have a project that you want to build on AWS, and the project is evolving. Maybe at the beginning, you might have, for example, something that is stored on some server somewhere, and you would like to store in AWS. The first step would be to do what we call a lift and shift. So you just take your application as is designed, and you put it on AWS. You transpose it to a public cloud. And then once on AWS, what we usually do is to choose the right sizing of the instance to improve the elasticity, to monitor, as we saw, and to measure, to optimize, and we do a lot of optimization. And then it takes some way to get to be true AWS optimized. As we saw, so optimization, it's something that it's important, and it's a long-term ongoing process. And here we have some powerful drivers that help us to achieve the cost optimization. The first one is the instance right sizing. So this would be to select the cheapest instance available while, of course, meeting the performance requirements. So we'll need to look at the CPU, we'll need to look at the memory, at the storage, at the network, to identify which is the best instance that I can use, and maybe what I can downsize also. The second point would be to purchase what we call reserved instances. So know that on AWS, you can use the services on demand, as I already told. You just request them and they are made available to you immediately. Or you can also reserve instances. And as there are different types and sizes of instances, it's interesting to reserve instances in advance, as they really offer great prices. The third one would be to increase what we call the elasticity. So the elasticity is using an instance when you need it and turning it off when you don't, as we saw in the example with the load balancer. So this is one of the most important tenets of the cloud. And often we go through a learning process to operationalize this work to drive cost savings. And when we combine these factors with the fourth ability, that is to measure and monitor, we are able to achieve the cost optimization. Okay. Something more different. So if you want to do something on AWS, first, you might check it on the marketplace. So know that there is an AWS marketplace, and chances are that it already exists. So bear in mind, AWS marketplace, it's a great place to have a look to see if you can find what you're looking for. Now, yes.
What are typical examples of what you mentioned now from the marketplace?
For example, if you want a WordPress website, if you want a specific AMI, it might be already there, and you don't need to build your own AMI. Would be let's say server image.
Mm-hmm. Okay, stuff like that.
Yes, and some other stuff. Yeah. Okay. So now I want to show you a simple architecture that includes AWS services. So there are going to be more services than we saw today, but you're going to see that it's quite simple to understand it. So yeah, I have my pointer. So here we can see that inside the region, we have our own VPC, own virtual network, and we are using subnets in two availability zones. So we have public subnets, and then what we call the application and data subnets, which are the private ones. So here we see that the customers are going through a DNS And then we can have a service that is just going to be located closer to the customers at the points of presence, for example, at edge locations. And then is going to communicate with our services in our architecture. We talked a little bit about the auto-scaling of the instances. So if we need more instances here, we can add new instances. Or if we already have like 5 instances and we see that we are using too many instances, we can shut them down. Yes, so this is an example of so it's a WordPress architecture. If you have some questions about it, of course, there are some services we didn't talk about them. Maybe from the names, it's easy to understand what they do, but I think what's important is just to have it as an overview of what an architecture might look like. Yeah. Okay. So before finishing, I want to say 2 words about certifications and available resources. So know that there are different levels of certification, starting with the cloud practitioner that is accessible to anyone who has little or some interest in the cloud computing. And then it depends, of course, on the knowledge and on your career plan. So if you're a developer, maybe you would like to pass the developer associate, and then the next step would be to the DevOps engineer certification, which is a professional one. Or if you're more interested in solution architecting, this one would be better. And then here we have some specialities. If you're interested in machine learning, which is a hot topic nowadays, there is also a certification that can help you gain the needed knowledge about the machine learning services on AWS. And there are some others. So there is, here are some links if you want to prepare for some certifications. Of course, there are trainings available. You can find some free trainings, but also some, of course, trainings that you need to pay for. And then here I put some links. So know that at the beginning, when you create an AWS account, you can use what is called AWS free usage tier during 1 year. So you'll be able to play around with AWS services within some limits, of course, without paying. So I think it's pretty interesting because it allows us to gain some experience and we don't need to invest some money. Then you can find some free labs. At amanox, we have our own academy, and we organize some boot camps that are free. And I think there are some boot camps. One infrastructure as code boot camp that is coming up. I need to check exactly the date, but it's a free event. You just need to sign in and to go there, and you can have a talk also with the experts from our team. And then re:Invent, it's the AWS global conference happening once a year in Las Vegas. So this year, of course, there's a lot of events. They are going virtual. So if you're interested, you can have a look this year from your couch. It's happening in December. And that will be all from my side.